Hello! Today we are going to solve a task on the topic of function. In the previous lesson, we gave you the concept of functional dependence and determined that functional dependence expresses the dependence of one variable on another variable. You will study the concept of function in high school. And now we will write down the functional dependence in the form of a formula. The task is as follows. We need to write down the functional dependence of the volume of a cube on the length of its side. To do this, let's remember the formula that expresses finding the volume of a cube. If we are given a cube and we need to find the volume of our cube, then our formula for calculating the volume of the cube, we have A in the cube. If we need to find the volume of a cube if the side length is 2, then by substituting into our formula, we can write that B is 2 in a cube. And that equals 8. Thus, if the side length of our cube changes, then it will change our volume of the cube. So I can write this functional relationship in the following form. Our volume depends on the length of our side, and as a result, this dependence is expressed by the formula A in the cube. If we need to find the volume of a cube if the side length is 5, then by substituting into our formula, we can write that B is 5 in a cube and that equals 125. But we must learn how to write this functional relationship correctly. Notice that in this formula, I wrote down that volume depends on length. If we had the length equal to 2, then we have calculated that the volume is equal to 8. I can write this down in a different form. If I need to find the volume when A equals 2, then the volume will be 2 in the cube and that's 8. Thus, the relationship between the volume of a cube and the length of a side is 2 equals 8. In the same way, I can write down that if I have a length of 5, then the volume that depends on a side length of 5 equals 125. Now let's write down another dependence. The dependence of the total surface area of the cube on the side length of our cube. This is the first dependence and the second dependence. We need to write down the area of the total surface of the cube. The area of the full surface of the cube. In order to find the total surface area, we're going to represent this cube and write down the formula for calculating the total surface area. What is the area of the complete surface and what does it consist of? The point is that the total surface area of a cube is the sum of the areas of all faces of this cube. If the area of one face is the area of a square and there are 6 faces. And then I can write down that the total surface area of our cube. Let's visualize it like this. Is 6 times the area of our faces, which is the area of a square. And we know that the area of a square is calculated by the formula A squared. And then we can write that the area of our surface of the cube is calculated by the formula 6 times A squared. And then we again have a functional relationship. The surface area depends on the side length of the cube, or we say the edge length of the cube. And if, in this case again, the length of our edge is 2, then our surface area, if the length of the edge is 2, will be 6 times 2 squared. And that equals 24. In the next lessons, you and I will write down formulas that will express functional dependence. And for today, our lesson has come to an end. Goodbye, see you again.